ठीक है सर. So this lecture is about the introduction to the Python. So Python is a high-level language which is used for numerical computation and nowadays used for machine learning and AI. So how to start with Python? First, you have to install Python for your platform which you are using. You may be using Linux, Mac, or Windows. So you have to go to the internet and search for the Python for your respective. But in the Linux, there is the latest version of Python is already installed for the platform. So you can use the basic Python, but not all packages are there. So you have to install those packages from internet, from using terminal, using install. What is the package name? Let us say it's NumPy.
Lalit, please increase the size of
Yes,
the
sir.
screen.
Okay, sir.
Yeah. Make it little more. Yeah,
Using
fine.
this command.
I think it's fine.
So if you the package is installed, then a message displayed on screen that requirement is already satisfied for the system. Or other packages, if you install SciPy, like AstroPy in another environment, you have to use this command. If you are using older version of Python, you can use only pip. If you are using the higher versions from 3, you can use pip3 to install that package. If you write Python on your terminal, then the Python of the latest version of the Python, which has been installed on your system by default, is displayed here. And this terminal will open, screen is open for your Python environment, and in which you can use your operations like mathematical operations, operators, summation, subtraction, all you can use here. But you have used other libraries of Python, you have to install those packages. Or if you have already installed those packages, you have to import those packages here. Like I am import NumPy. If I import NumPy, so I have to use like linspace. The linspace. Okay, I have to use arguments here. -2 star pi, comma 2 star pi, about 10 points. Okay. So here there is an error in here displayed here that linspace is not defined. So you have imported from NumPy. You have to install write this NumPy dot linspace. Okay, now pi is not there, so you have to also use the pi from there. That is NumPy dot pi to this NumPy dot pi. So it is a very tedious job to always use NumPy. So we use import NumPy as you want. Okay, I am using import this NumPy as most probably it is used as NP. You can use whatever you want. So now if I have to give an array, now I will write only NP dot this linspace, and this already this is minus pi to pi, and again pi, you have to use np dot pi to np dot pi, and how many number of equidistant points you want, you can write it. And if you type x, then this equidistance point from minus pi to pi are displayed here. But always you are using np here. So if you have to plot wind or plot something, you have to import matplotlib here. If you are doing some scientific calculations from scientific packages, special functions like error function, you have to use SciPy and import SciPy, and from import SciPy you can use those functions. But there is always a simple way, that is Ipython notebook, Ipython, where you can use those functions by default by using a flag -pylab. So I can quit here and move to there. So if you write Ipython, like Ipython3 space hyphen with a flag of pylab, those functionalities like NumPy, SciPy, and other matplotlib, other packages are already uploaded or loaded to the system. So you could not use that np dot scipy dot or import numpy, import scipy. Let us say, for example, I write this x equals to linspace some values, that is minus of pi, minus of pi to pi up to 10 points. So I did not use like import numpy, import scipy, import matplotlib, or you can use the plot command also here. Plot x comma, that is not used to use sine functions, use sine of x. So you already given and the plot window appears here. So this is an easy way to use. If you first understand all those things, after that you can use that in general Python terminal, import those packages and do all the calculations. So it is very easy to use here. And now I am used to plot this plot windows, and what is how to label those windows here. So here there is a control is always given back to the this terminal, not to the plot window. So you could
ललित,
change all those commands here and those changes. Yes sir.
ये हमने कर लिया इसके आगे वाला.
Yes, sir.
अब हम शायद फंक्शंस को देखते हैं, डिफरेंट फंक्शंस कैसे दिखते हैं, या इक्वेशंस का सॉल्यूशन, या सपोज स्क्वायर रूट निकालना है, क्यूब रूट निकालना है. आई थिंक मैथमेटिकल ऑपरेशंस की थोड़ी सी बात कर लेते हैं, या बिल्ट इन फंक्शंस की थोड़ी बात कर लेते हैं इसी में, बिकॉज वी हैव डन इट अर्लियर, राइट?
Yes sir.
Okay.
For plotting, there is a different options to plot command plot. There is another option. You could use a figure window and then plot this plot on that figure window and use all those commands for the same figure window. Let us say I have to plot two functions. We have not discussed that earlier. I have to plot sin x in a different figure window and cos x on a different figure window. So you could use this command, that is figure, and give a name to this, that is figure 1, and a figure window appears here, that is figure 1. And if I steal another figure, okay, figure 2. So another window appears here, that is figure 2, and you can change the control by typing figure 1 and then plot the function here. So I close all those figure windows. So there is no figure window open here. So now we can use the mathematical functions which have and plot the different functions, how they look. Simple sine or cos function we have already studied, and now we use to the hyperbolic functions, how they appears. So I am I'm plotting this function, this plot x comma sine of hyperbolic using sine of h, and plot window appears here for the hyperbolic functions from minus pi to pi. If you have to some other functionalities, you can move to the help option, and what is the sine hyperbolic function, you can use it here. So this can give you the help about the sine function, what is a sine function, what is, how can plot you, and other elements, and with examples you can find the examples. And there's the equivalent expression which we have used, that is exponential x minus x divided by 2 iota. That is j is for imaginary number, and this is examples for that. And you can use you can also plot the quadratic equations and other mathematical functions, square roots, cube roots here. So like I have this x equals to this linspace 1 to 10 up to 1 to 10, just 10 points are there. So you can use a square root function. So y equals to sqrt. Okay, if you're using this, you can use from the numpy that an np dot square root, but there is no need to write np, so you could only write the square root of x and then type y, and the array from the square root function is here from 1 to 10. And you could do the cube roots like that. The cube root, I can use cube root using x raised to the power this 1 by 3. This is the cube root for the functions for x. And you can plot other functions like what is the quadratic equation. Let us say I have a quadratic equation that is the constants a equals to 2 and v equals to 5, and let us say the constant c equals to 10. Okay, so I can write a function like that, a quadratic equation that is ax square uh, ax square plus this bx plus c. Okay, so this is array which we have used for ax square. Let us give another example. For let us plot this y equals to ax square plus vx square plus c, and now I'm writing plotting this function. Plot this x comma this function x comma y. Okay, so this is if you have the previously plot one plot here, and again you plotted the x comma y, you could use the clf, that is clear the figure window command. So there is no plot there, and only a figure window appears here. Now you could plot. Now you could plot the functions plot x comma y, so that the quadratic equation function appears here. And now I am writing a function to annotate the function. How to annotate the function if you have some values? So I am clearing the figure window and I am plotting some hyperbolic function. That is secant hyperbolic function 1 upon cos hyperbolic of x. And now I am changing the interval. It is x is equals to linspace. So there is a help again here. If you press tab, then there is a command, the linspace appears. Tab completion linspace minus of this 2 pi to 2 star pi about 100 points. In plotting this function, so use this function from minus 2 pi to plus 2 pi appears the cos hyperbolic, that's a secant hyperbolic function. So if this is the maxima of this function and I want to display where is the maxima of the function, so you can use the annotate command to here. It is like annotate annotate annotate. Okay, you could use, there is a first I will display the help option for you. Annotate, if you press again tab, this is the function like text. It is a first option is string. You could write their maxima, minima, and there is the x comma y. Then you could use the values, that is the whereas the function's values x comma y appears the maximum. Let us see, here is the maxima is about x is 0 and y is at equals to 1, and this is like a tuple, that is you have to given the data in the simple parenthesis, and again you could do the x comma y text here for next if you are using arrow options for there. So I could use the annotate. So first is string, so we are using a string that is called maxima, comma, what is the coordinates for x or y, and this should be tuple, so this could be given in the square brackets in the simple parenthesis. So you could write x coordinate is 0 and corresponding y is at 1. So the maxima appears at that point. That is the maxima of the function. Your local maxima, local minima, you should always write there. Another option is that we are using the plot window in a single plot window. So if I have to compare the more than 1 or 2 plots, not in the single plot, so you could use the subplot windows. So you always partition this figure window to required functions, like you use 2, 2, 4 windows, subplots. So you could use 4 plots in a single plot window, 8 plots, 10 plots. What you want, you could use here. So I'm moving to the subplot windows. So for that you have to use command subplot. There is a command subplot and there is a command subplots. In the subplots, there are the only 2 options: how many rows you want, and how many columns should be there. If there are 2 rows and 2 columns, there are the 4 plot windows. So 2 cross 2, that means 4 windows should appear there. The 4 windows. Okay. Now how to move? Let us say I have to plot this secant hyperbolic function. This is the index for this is 2 comma 2 comma 1. Okay. And for the 2 comma 2 comma 2, this is 2 comma 2 comma 3, and this is 2 comma 2 comma 4. So you have to move the control to their specific subplot. So there is a command called subplot, and you can do the index, that is the second row, again second column, and what is the index? It is 2 comma 2, that is 2 comma 2 1, 2 comma 2, 2 comma 3. I am writing the 2 comma 2 comma 4. Okay, the last window, control move to this is the last window, and now I'm plotting function here, the plot this secant hyperbolic function. So you could plot this secant hyperbolic function here. You could plot the cos hyperbolic, sine hyperbolic, and tan hyperbolic functions, and then show the students to how these functions look like. So again, I'm looking back to the subplot, moving control to another subplot window. It is subplot 2 comma 2 comma 1, and I am plotting here as cosecant, it is sine hyperbolic 1 upon sine hyperbolic. So this is the cosecant hyperbolic function. So you can move to the control to this window, and you could plot many functions as you want. And there are other functions which we have to in our field, we have to plot these multiple windows and compare them. And there are these, if there is you want some changes to these windows, there are another options available. That is, some controls are there. We have subplot tools here. Okay. So a plot window appears, again a pop-up appears, and you could specify the spaces. Let us say I did not want the horizontal spaces between these two and these vertical spaces. Okay, I do not want those spaces. You could already given here and change this to 0. Okay, the horizontal spaces between subplots windows disappears, and again the vertical space है वो भी अब जो change हो जाएगा. And you could use the tight layout so that these functions move to the maximum size of the window, and again you could use those functions like 0 and this space equals to 0. And now you can always remove those axes and plot whatever windows you want to plot here. This is about the subplots, and this is very useful when you are using multiple plots and display on the single graph. They would appear. And another option, we are plotting some another functions like how to import some other function, mathematical functions. You could use the help here. You could use the math. Okay, the math is not defined here. Trigonometry like sine function. So you could use the help function to appear here, sine function. In other options, you could already given here what you are using. You could use what functions you want here and use those functions. So beauty of the Ipython, this PyLab, is that you could not use to define the word from where the package is imported. Your function is imported from numpy, scipy. It automatically works here, and it is very easy to use. So it is enough for today, sir.
ठीक है ललित, थैंक यू.
थैंक यू सर.
कल भी कोशिश करेंगे इसी टाइम पे. ठीक है, ओके, थैंक यू.
ठीक है सर.